AgNO3, so that would have to be silver nitrate, and the silver has a fixed ionic charge, so it's just silver without any Roman numerals, and then the NO3 of course is a polyatomic ion called nitrate. Then we're going to go to the KCl, so that's potassium chloride. Same thing for the potassium. As a member of the alkali metals, the potassium has a fixed ionic charge, and so do the alkaline earth metals, so groups 1 and 2. So fixed ionic charges means we don't have to put any Roman numeral there, as you know, only for variable charges. So that means on the right hand side the same thing is going to happen, and as you can see they just switch the ions, so potassium nitrate, silver chloride. Here it's advantageous, really advantageous, to start with the polyatomic ion and notice that it stays intact. So NO3, we just consider that to be one entity, so we have NO3 on the right, we have NO3 on the left, so it's going to be a 1 here and a 1 there. Now we're going to look at the silver, 1 silver here, 1 silver there, so we're going to put a 1 there. Now we're going to look at the chlorine, 1 chlorine here, and so 1 chlorine there, and now finally we're going to do the potassium, 1 potassium here, 1 potassium there. So in that case the equation is balanced with all coefficients being 1. So here we got nitrogen and oxygen, and this would be nitrogen oxide, but both of them are nonmetals, so this will be dinitrogen trioxide, and there's no way around it. We have to name it like that, because if we leave any of these tri or di out, it would be indeed a different compound, and only the dinitrogen trioxide will tell us it's N2O3. Okay, we're going to balance on, we're going to look for the element with the most atoms, and it's the O3 over here. So we have an O3 here. On the left hand side we have an O2. Notice that of course this one is even and this one is odd. Whenever that happens, that on one side we have an odd number of them, well, we definitely need to make that even, so we definitely need to double it at least, and that's what I'm going to do here. So it's going to be 2 N2O3. So we have 6 on the right. That's even, of course. And then on the left hand side we have 3O2 in order to match those 6. So 6 here, 6 there. Now we're going to look at the nitrogen. So here we have 4. That means on the left hand side we also need 4, so we're going to put a 2 in the front. And as you can see, that is balanced. 4 nitrogens, 6 oxygens, and 6 oxygens. NH3 has a common name that you must be familiar with: ammonia. NO, another one of those nitrogen oxides, but we need to call it nitrogen monoxide. That one, of course, is nitrogen, and the H2O, of course, is water. Okay, let's see. We're gonna touch the nitrogen last because it appears in too many places. So it leaves us with the O's, which appears in 2 places, and the H's that appear in 2 places. So we're gonna have here 3 hydrogens. That's where I'm going to start out with, because it has the most atoms. So 3 hydrogens here, 2 hydrogens there. That means that this one here has to become even. So I'm going to put 2NH3. 2 times 3 is 6. That means I need a 3 here. 3 times 2 is also 6, so that's okay. Now that means I have 3 oxygens. That means I need 3 oxygens over here, so I have 3. Okay, so far so good. The oxygens are balanced, and so are the hydrogens. Let's look at the nitrogens. We have 2 nitrogens here and another 3 here, so 5. Keep in mind that's odd on the left hand side. On the right hand side we have N2, that's even. We need some more of these here, but we also need to match the even and the odds over here, and the only way we can do that is if we make an even number out of these 5 here. How do we do that? Well, we double, and that means that I can't just have 3 nitrogens here. I need to double them. So I'm going to erase that 3, and this happens. You do that sometimes. You have to do that. I didn't make a mistake earlier, but instead I need to amend what I did. So 6N, well, now that would upset actually the other 2 components that I already did. So what we do is we double those as well, because when we do that, then at least the hydrogens and the oxygens will be still balanced. So it's going to be a 4, and then over here that's going to be a 6 as well. And I didn't mean to erase the hydrogen. So it's going to be a 6 here. Notice, just to check, as I doubled everything, of course the hydrogens and the oxygens still need to be balanced left to right. So here I have 12 hydrogens, 4 times 3, and here I have 6 times 2, 12 hydrogens. I also have 6 oxygens, match the 6 oxygens over here. So now, as I doubled this, these compounds that I touched so far, I made on the left hand side, I made the nitrogens, the number of nitrogens, I made them even. So I have 4 and another 6, which is 10, and that means I need 5 of these here, 5 nitrogens. And again, you can check that, and of course I did that a moment ago. I checked all these elements, and they do balance, and yeah, these coefficients are quite large, 4, 6, 5, and 6.